Hi, my name is Min, and I will show you my Python code of CECS174 project number 4. And this project will be, with this project, the main goal of this project is to find the persistence and root of, uh, of a number entered by the user. And there are two types of persistence and roots that we are looking for. We're looking for the additive persistence and root, and also the multiplicative persistence and root. So as we can see right here, where the background is asking for additive persistence and additive root. Also, in the middle of the project guideline, it's also asking for the multiplicative persistence and multiplicative root. So let's go over my script, my Python script for a moment. So my Python code is consists of only one main loop, which is the top right here, and it's the main while loop, and it's stating while true. The reason that I pick while true is because um, every time the user enter every time the user enters a number, because every time the user enter a number, that number will always be true instead of a zero. And in this case, if we enter a zero in here, like the second line of my code, as I highlighted, if I or anybody enter a zero in there, the um, the loop will completely shut off and you know discontinue. So my main while loop will consist of two conditional statements. The first conditional statement is if the number is less than zero, it will tell the user that tell the user that thank you for playing the number game, and because they enter a negative number less than zero. And also I also print the process finish with exit code just because in the example of the project it says right here, so I'm just gonna do it for just in case. and and after the users after the user input a negative number, for sure it will break off the while loop. Well, from that conditional statement, the while loop will be broken off and discontinue, because we don't want because not that we don't want it, it's because a negative number can't be used to find the persistence and the root, the additive persistence and root, and the multiplicative persistence and root. So the two conditional statements. The first was the number is less than zero, then break it off. And the second one is else, which means anything else. And this conditional statement is really condensed of all the mathematical operations in order to satisfy how we calculate the all the persistence and the roots. So there will be a while loop, a nested while loop, and nested else conditional statements in here. And there are two sections. First section is for my my first section is for the multiplicative persistence, and the second section is for the additive persistence. As you can see right here, additive loop and multiplicative loop. So going more into detail about my code. So inside of the nested loop, while nested loop, the remainder one, rem, which I name it rem1, is equal to num1 um, num1 module 10, and that will give me a single digit number that will match with the last digit that the user is inputting in. Oh yeah, I forgot to tell you that I have a since I have an input statement right here, which is called number, and that number I will split it into two variable, which is num1 is for multiplicative loop, and num2 for the additive loop, because we don't want to use the same number for both loop, because the name will be consistent throughout the nested loop of each of either the multiplicative loop or the additive loop. Um, which I have steps right here, which means it shows how many steps it takes. The steps is also called can be the step one value. I will use that for the persistence, because by definitions, persistence means how many times it takes for the number to become a single digit number after multiplying or adding. And yeah, so rem1 will give me the last digit of the number, the last digit of that number the user's inputting, and the product will be in iterations. It will be, since it will be a while loop, it will be in iterations, and then the rem1 value will eventually go over every single digit of every single digit of a number that the user is inputting. And since the only difference between these two sections are that I use products, which multiplies right here, instead of the other one, which is sum. Sum is for the additive loop, which I will add every digit of that number. But by definition, that is true by definitions. And for multiplicative loop, I will multiply every single digit number. Not every digit of a number entered by the user, to be more clear. And this one will give me the next number, I mean the next digit of that number, and iterate again to find the next digit in that number. So yeah, after those else statement, so my second conditional statement of that main while true loop is starting from line 18 all the way down to line 52. And that is because I want to condense all the mathematical operations to to uh, to find the multiplicative and additive persistence root, additive persistence and root. Okay, so now I will go over the examples. So first example will be 1234. That's 1234. Oh wait, never mind. I need to run the code first. Okay, so 1234. And my code is providing the same thing as the example is providing. A products of the 224, a products of 224, I mean 24, products of 24, second products of 8, and here it is again. Since there will be two series or two iterations of a product, down here, multiplicative persistence of 2, and additive loop, and inside of the additive loop, I have a sum of 10 and a sum of 1, since it took two iterations to get to single digit number. Then my additive persistence will be 2. And the single digit number will always be the root of each method. For the additive root, I have an additive root of 1, same things right here, and also the multiplicative root of 8, same as here. And as we can all see that enter my after I enter after I or any other user enter a number 1234, the the program will continue to ask for more because this is an infinite loop that I created because the user is gonna be playing this game, is gonna use this calculator how as many times as they want. So I can enter another number again, which I will follow the examples. It's 999,999, so triple nine, and here it is. It gives me a product of 720, and so on, and it takes 4 iterations to get to the single digit number. So then my multiplicative persistence will be 4, and my multiplicative root will be 2, as it is right here. And for the additive loop, I will have a sum of 27 and 9, and that is 2 iterations. So there will be 2 additive persistence, and the additive root will be 9. So again, I will continue through the examples, and if I enter a negative number like this one on the project guideline, on the project example, -1, but I'm sure I can use a different negative number, let's say -456, and let's see what will happen. It will tell the user, it will tell us that thank you for playing the game and goodbye, and also the finish process finished with exit code. That is something I intentionally printed somewhere up here. That's what I intentionally printed in order to match with the example, just in case if I lose points for that. And then for the next part of the examples is that after I or the user is entering a number, it won't show the iterations products and some summations of all the digits. So simply, I can remove that by just deleting these lines, printing the iterations. I mean, printing the products and summations every iterations. So I can delete these, or simply I can just comment it out. So I will give it a hashtag in order to deactivate it in the code. And if I run again, so 1, 2, 3, 4, and here it is. I don't have, well, I do have, the title of a multiplicative loop and additive loop, but I can simply remove that by commenting out these lines up here, because that's just how I want to format my code, my output. So I can do that again. Let's close the loop and clear everything. Okay, I will comment out these hashtag and hashtag in order to match with the example. So if I run again, 1, 2, 3, 4, here it is. For the integer 1234, my additive persistence is 2, additive root is 1, and my multiplicative persistence will be 2, and multiplicative root will be 8. Same here with the example. And if I enter 999, it'll give me an additive persistence of 2 and additive root of 9, same as here, and multiplicative persistence of 4 and a root of 2 and multiplicative loop, same as here. And I can try a totally different number that is that isn't from the example. So I can try 7,623. Let's see what are the root will be, what the root will and what the root and persistence will be. And I do have an answer, which will be additive persistence of 2 and additive root of 9, multiplicative persistence of 3, and a multiplicative root of 0, which is which are true after if we operate some hands calculations um, in order to double check with the multiplicative roots and all the persistence. And I can try some new numbers such as 789 and see what it will be. And here it is again. We have all the answers here, all four answers. And if I want to close the loop, I can just enter any negative number as long as I want. So that's a negative infinity, I guess. And my program is nicely asking the user, I mean, not asking, tell this user, thank you for playing the game and goodbye. And that is all I have for today's project. Thank you.